Hello everybody, in today's video we are going to have a very cool lab discussion on packet capture. Packet capture is often referred to as network sniffing or packet analysis. This is a process of intercepting and logging the data traffic passing through various computer networks. This technique captures the packets of data as they travel between various devices on a network, which helps in analyzing and examining the network activity. So let's say four computers are there in a computer network and they're talking to each other. So the data flow that happens between them is what is captured by a packet capture device. It is commonly used for troubleshooting network issues, monitoring network performance, detecting security breaches, or analyzing various network protocols. It provides valuable insights into the flow of data within a network, helping network administrators and security professionals to understand, diagnose, and resolve various network-related issues. Now, let's go through the bullet points of today's video. Number one would be, we will be using a packet capture tool called TCP Dump in order to dump the network traffic packets, which will be later used for analyzing. We will be dumping the packets in a .pcap format, which is a widely known format for packet capture. Second, we are going to go through the Wireshark tool to check the pcap file that was generated through TCP dump. Third step would be, we will be using a database like MySQL in order to label the data based on ingress or egress. So we will be labeling the data. Let's say if it's an ingress traffic, we are going to label that and add a new column with the data 1. Or if it's an egress traffic, we are going to label the data as 0. So it's basically like adding a whole new column with the network traffic type, and accordingly we are going to label the data, giving it a value of 1 or 0. Fourth step would be for us in today's lab would be to export this database that we have done, export the table in the database in a CSV format. CSV is a tabular format. We are going to export it into a CSV format. Fifth step would be to import that CSV into a Python script, which we will be writing live on this video. And this Python script is going to invoke a machine learning model and define the accuracy of the model. Let us now start the TCP dump tool in order to capture the packets. Just exit out of this nano editor and we are going to run the command called sudo TCP dump. Sudo is used to run it as administrator. We are going to define the tag I for the interface. For us, it will be a wireless LAN 0 on this device, and we are going to write that data as captured data.pcap. So pcap is the file format that we are going to use, and let's say we are going to run this kind of script. So now we can see that TCP dump is listening on my WLAN 0 interface on the Ethernet. So now what we're going to do is let's make some traffic for it. As we can see that this device which I'm using at this point of time is not having any incoming or outgoing traffic in itself, but we can create or generate one for it. So let's say I'm just opening a new terminal, and in this I'm going to ping, let's say google.com. So we are just basically pinging google.com from this particular device. We'll just end that. Let's say now I'm going to ping facebook.com. So these are just random websites that I'm pinging in order to generate some traffic flow. Next, let's say we're going to ping twitter.com. Okay. So these are just random traffic that we are generating. So these are all going out. So we are just connecting to these websites right now. Next step would be to get an incoming traffic. Let's say someone is pinging our device. So I'll just open up a terminal and I'm going to ping. So this is pi.local on my network, So I'm just going to ping pi.local, and we can see that the ping is successful, and the IP address which we are using for the scanning device is 192.168.0.246. So this is the total ping. So we had incoming ping as well as outgoing ping to several websites. Let's do one more website. Let me do my website for now. Let me ping it here. So that's what we can do for generating the traffic. And we will just exit out from this TCP dump. We can see that we were able to capture 3,766 packets by running this TCP dump tool. We can let this tool running in a live network for, let's say, like 10 or 15 minutes or even half an hour or more, and we can get a huge chunk of packets which we can analyze and reference for our purposes. So now we can see that this is the captured data.pcap which is generated because we were asked the tool to write it in this particular file format, and this should be the name of the file. So the tool had given us this captured data.pcap file. Now, how do we open that pcap file? So this machine is on a different network. So we are going to quickly go to SFTP, and we can just go to projects, packet dump, and this is the packet that we have, packet file, and this is around 355 kilobytes. We're just going to double click on this, and Wireshark opens up with that entire list of the packets. Along with that, we have the time, source, IP, destination IP, protocol that is used, length of the packets, time to lift, and more information on those packets. So even Wireshark shows us that there are around 3,699 packets that has been captured, and we can analyze this data by, let's say, if we are going to see the source IP to be let's say what was the IP address of our machine. It was 192.168.0.246. So this is the IP address of our machine. So we can do ip.src equal to 192.168.0.246. So this is basically a filter which you're going to do, and here this is going to show us all the packets that have the source IP as 192.168.0.246. So the packets that were moving out of our current device and pinging. So this, all of them are all TCP protocol packets, and we were pinging various websites. So these are the destination IP addresses. We can also do the other way around. So these many packets are there for this scenario, and we can do multiple other things, like we can also do destination over here, like DST. So these are all the packets which have a destination of 192.168.0.246. So packets were destined towards this machine of ours that we are using at this point of time. So like this, we can use various filters in Wireshark in order to analyze the traffic. So right now we're just going to keep it as it is, and what we can do now is we can just save as this file. Let's not save it at this point of time. What we can do better is we can just do export as CSV. This would be the best method. Now we can just go ahead with desktop, and what we can do now is just name it packet capture CSV. So this is a comma separated value in CSV. We are going to packet range should be all packets, so all the packets would be exported to the CSV. And now let's do save. So in our desktop, we should have this entire packet list.csv file, which we can use with other softwares. Like the next step for us was, let's quickly open up that next step panel. So we can do now this. We were able to do this TCP dump of pcap. We used Wireshark to open that pcap file, and then we had exported it into CSV. We can import that CSV in a database solution, let's say MySQL, and we can add this column. So next step for us would be to open up a database viewer and create a database with the CSV file that we just generated. So now for database, we can open up a tool called dbeaver. Dbeaver should be up and running in a moment. Okay, so here in localhost, we have this, in the very left corner, we have this databases. You can right click on the database, create a new database, and this asks for a database name. We can keep any database name for a packet. We are just going to go ahead with packet underscore dump and click on OK. So this created a database for us. There should be having an option to import data. So here we're going to have an option import data. We have a CSV import mapping. Go to next. We click on that packet capture.csv which we just exported from Wireshark. Then we can again go to next. This is the packet which is packet capture.csv which is having a mapping of create, so it will create it for us. We can truncate the targeted tables. Okay, everything seems to be okay. Good to go. Now we can just click proceed and that entire CSV file will be loaded into our database. Now let's click on proceed and the data should be in our database. During batch insert, data translation. Okay, so the info table which we were having previously seems to be too long. So what we can do at this point of time is we can just stop this transaction for now. Click on OK. We're going to remove this database as well. So the info table is something that we will not be needing at this point of time. So what we can do is yes, delete the database. So we'll just quickly open up Wireshark once again. So what we'll do is we'll just pull that packet again from SFTP. We have this captured data.pcap to just open it in Wireshark, and now this info column is something that is taking up a lot of space for our database. So we need to either truncate this or we can just remove this column altogether. So we can do is we'll go to column preferences, info, and we're going to remove this column. Okay, that should be gone. And next we can again export this file as CSV, and we'll just go ahead with desktop. We can name it packet capture.csv. I'll replace it for now. Yes, so that should be done. Now let's open up dbeaver once again and check if it works at this point of time. Now we'll open dbeaver. We are going to create the database again, and we are going to, what was the name of the database? I just forgot. It was, I think, packet underscore dump. So we'll just name it the same, packet underscore dump. Okay, right click. We're going to import it from import data, import source CSV. We'll this is the packet CSV. Then we'll go to next, proceed. So now we are good to go. So this entire database was created from the CSV file that we just generated, and it is, I think, having around 3699 packets, which as we saw on Wireshark, it was the same on Wireshark actually. So as you can see, there are 3699 packets, and all these 3699 packets were imported into the database. And we have all these columns, number, this is just the serial number, the time, source, destination, protocol, length, and time to live. So this is the entire packet capture which is imported into our MySQL database. So now what we're going to do is, the next step for us would be to update this particular database of packets and add a new column just over here beside this time to live, which is going to be having a condition. Like the table name is packet capture over here. These are the default columns. We can add a new column called traffic type. So in the traffic type, what it is going to happen is we are going to check if the source IP address, that is, we'll take up this and we'll check if the source IP address is our machine IP, that is 192.168.0.246. Like you can see over here, we have one packet like that. Then we are going to keep the value of the traffic type as 1, or we are going to check then if the destination IP address is 192.168.0.246, like in this case, then we're going to keep it as 0. So basically that traffic type column which you're going to create right now is going to either have value 1 for the source of our machine IP, or 0 if the destination is our machine IP, or we can keep it as null if in case neither of these conditions meet. So for that, what we can do right now is we can go ahead with SQL Prompt over here. Let's make it a little larger so that it's visible properly. Okay, so we're going to use a prompt called use packet underscore dump, which is our database name over here. We can see over here packet underscore dump. We'll run it. You can see that this has been executed. Next, what we can do is we're going to alter the table, that is alter table. Our table name is packet underscore capture. So packet underscore capture, this is our table name. And what we're going to do is we're going to add a column called traffic type, and we're going to keep it as integer. Perfect. Now if we run this, this is also executed perfectly fine. Now we can just go ahead and click F5, or we can just click on refresh over here. We can see that a new column traffic type has been created, which is having all the values as null at this point of time. Perfect. Now what we're going to do is we'll remove this again once again. Now we're going to update the captured data table, that is in this case it is the packet capture. Now here we're going to set the value of the column, that is traffic type equal to, and we'll use case over here. So first case for us would be when source equal to 192.168.0.246. At this point of time, print it as 1. Next check if destination is equal to 192.168.0.246. In that case, 0. Otherwise, if none of these conditions meet, keep it as null. So we're going to check again if the machine IP was correct. So we were pending pi.local, it's 192.168.0.246, and here also we have kept it the same. So this should work for us. Now let's run this query without a where clause. That's perfectly fine with me at this point of time. So it shows updated rows 3699. So all the rows are now updated, and this column should be appearing to us. So now it's still showing as null. Let's refresh the debugger, clicking F5. So now we can see that all these values have been updated in the traffic type. Some of the values might be null, like these cases, because there were some IPv6 addresses that are used instead of the IPv4 address. So these are kept as null for now. So that is not an issue for us at this point of time. So traffic type has been created, this column has been created, and values have been populated for us. Now what we are going to do is we are going to export this updated table by clicking on file and then going to export. And export, we are going to choose an export method. It should be having, I think, CSV format. If we don't do export, or we can go ahead with file, we should be having an option to export this. Or what we can do is instead of file, we'll just go ahead with packet capture, export data over here. Okay, and then we'll go to CSV, extract type single query, go ahead with next. So these are all the stuff. We can keep it as default. Next, we'll move ahead with desktop, open. Okay, file name pattern is perfect with us. We can compress it, which is not required at this point of time. Click on next, and then we'll click on proceed. So now we can see that packet capture was complete, and this new database has been created for us inside our desktop database in a CSV format. So what we can do right now is we can check that CSV file as well, but what we're going to do is we're going to open up a VS Code inside this machine, and what we will do is we will just drag and drop that packet which we have, CSV file which we have captured, and we can see this is the entire packet underscore capture file with our last columm value, which is the traffic type. So this is the updated CSV file which we just generated. Now I have a train_test.py file that is generated inside this project. So in this, what we're going to do is we're going to write a very simple script. Just expand this a little. Okay, I'm going to create a simple script where we're going to import some basic libraries like import pandas as PD, because we're going to read that CSV file. Now, Copilot is already giving me a prompt import numpy as well, but at this point of time, I don't think we'll be requiring numpy. So what we can do is we'll go to sklearn. Copilot is already writing stuff for me at this point of time, so I don't know what to do. So okay, from sklearn, it is also showing me a standard scaler, but I think I will not be needing it at this point of time because we're just going to open up as ensemble import. Okay, random forest classifier is good for us. Okay, now for metrics, it is showing us already as accuracy score. Let's keep it as it is. Also, what we can do is we can create a classification report. Good enough. Along with that, confusion balance. Perfect. So Copilot wrote most of the code for us, and I'm good to go with that. Now what we can do is we will load the CSV file using the pandas data query. So we'll do df equal to pd.read_csv. This is also written by Copilot. Now instead of data.csv, we're just going to copy this name, rename, copy it, and paste it up over here. So this is done for us. df has been given the value. I don't need a semicolon over here at this point of time. So okay, and we're going to df equal to, we're going to drop the any values, and what we will do is df.drop it. Okay, perfect. It gives us all the solutions. Subnet equal to, and we're going to keep it as traffic type. Okay, so what we'll do is over here is we'll drop the rows with null values in the traffic type column. So some of the values, as we know, they were kept as null where our conditions of source and destination did not meet, so we kept it as null. So we're going to drop all those packets at this point of time from our data frame. Now we can convert the categorical variables to numerical using a one-hot encoding method. So we'll do is df equal to pd dot get dummies, as it is already showing up over here. Get dummies, we will keep it as data frame, comma, columns. Our columns can be equal to, let's say, source, comma, destination, protocol, and traffic type. But at this point of time, traffic type is not required over here because we are using traffic type to analyze the data based on ones and zeros. So we will just keep it as source, destination, and protocol. So these are the three columns that will keep it to convert it into a numerical value from categorical variables. So now we're going to split the data into features x or target variables y. So what we'll do is x, it is already showing me over here, df.drop. So we'll do is df.drop, and we'll use the columns tag over here, columns equal to traffic type. Copilot is basically doing majority of the code for me. Okay, y is equal to df.traffic type. So this thing is also done. So x over here is the features. So let's keep it as features. So I'm just writing it over here. Since this is Python, we'll keep hash. Perfect. Next, this is the target. Okay, we'll keep traffic type as the target. Next, what we'll do is we'll split the data into training and testing sets. We'll keep a 70-30 ratio, that is 70% of training and 30% of test data. So what we'll do is x underscore train. So this is also written. Now train test split, we are using this from the sklearn model selection. We keep x, y, and the test size, since we are keeping it as 70-30. So this should be test data of 0.3. This is 30%. Random state is 42. That's pretty good. Now what we're going to do is we're going to train the random forest classifier which Copilot just imported for us. So we'll do clf dot, we'll first give it a name, random forest classifier. Okay, and we'll give it random state as 42. Perfect. Now we'll fit the data, clf.fit, with the x train and y train. It is done. Now we'll predict the target variables on the testing set. So what we'll do is we'll define a value y pred equal to clf.predict x test. That's perfect. Now we're going to evaluate the model. How do we evaluate? So over at this point of time, we can evaluate the model. So for evaluating the model, what do we need? We will declare a value called accuracy to check the accuracy score based on white test and white. Perfect. We'll print that accuracy. Next, what we'll do is we'll generate the classification report, because we just created this classification report over here. So what we'll do is print classification report, and then we're going to print the classification report of white test and white test. So these values are going to be exactly the same, just we're using first accuracy score and then classification report. Third thing that we imported is a confusion matrix. So next, what we can do is we will print the confusion matrix. Confusion matrix. Okay. As far as this will be confusion score. So this we have not defined yet, confusion matrix. So what we'll do is we'll go up over here, we'll define confusion matrix with confusion matrix of white test, white test. This is good enough. So what I can tell at this point of time is Copilot did a very good job at writing most of the things that I'm thinking. So whatever I'm thinking, it's just writing it down on my screen. Perfect. Now I'll just save it over here, open up a terminal, new terminal. This is our directory. I'll just zoom out a bit. Okay. And next, what we're going to do is we're going to run this Python file with train_test.py file. So after clicking on enter, this will run this entire Python script and show us these three things, that is accuracy, classification report, and confusion matrix. Now let's click on enter. Okay, module not found error. Okay, so all these modules that we have just imported needs to be installed on the system as well with the command like pip3 install pandas, or let's say sklearn. So like this, all these things need to be installed in the directory. So for now, what we're going to do is I'm going to use conda and activate the environment MLP. So this environment was created by me previously, just to where I'm having all this data, like all these modules imported already. So all these modules already downloaded. So I'm just going to use conda activate MLP. So now what it does is it changes my environment base to MLP. Now I'm going to run the exact same thing again, python3 train test.py. Let's see. Okay, we are having some errors being thrown up. Opening or an expert keyword subnet. Okay, I think it should be subset, not subnet. Okay, here, oops, should be subset. Working on a network project, so everywhere and whatever I'm seeing is just subnet. Okay, good to go. Now let's run it again. Perfect. So now this code executed properly. You can see an accuracy of 100%. That's good. Classification report, and we have the confusion matrix. So seeing this, what we can understand is basically accuracy, it measures the percentage of the correctly classified instances out of all the instances that are there. Here, the accuracy score of 1.0 means that the module correctly classified all the instances, like the model which we had just created, classified all the instances in the test set correctly. So it's got a score of 100%. The classification report that we see over here basically includes precision, recall, F1 score, and support. Precision, what it does, it measures the accuracy of the positive predictions. So precision, it is the ratio of the correctly predicted positive observations to the total predicted positives. Recall, what it does is it measures the ability of the model to find all the positive instances. It is the ratio of the correctly predicted positive observations to the all observations in an actual class. Third is our F1 score. F1 score, what it is a weighted average of the precision and recall. So it is the average of this and this, weighted average of precision and recall. Therefore, this score takes both the false positives and the false negatives into account. Now, support, the fourth column that we can see over here, it is basically the number of the actual occurrences of the class in a specified dataset. For both the classes 0 and 1 at this point of time, we can see that precision, recall, and F1 score are all 100% at this, indicating a perfect performance. Support indicates the number of instances of each class in the testing set. So this is having 100% as well. Now, the third thing which you printed is a confusion matrix. Confusion matrix is basically a table, as we can see over here, that is often used to describe the performance of a classification model on a set of test data for which the true values are known. It is particularly useful for understanding the performance of a classification algorithm. Each row in the confusion matrix, as we can see, represents the instances in a predicted class, while each column which we can see, that is columns, each column represents the instances in a actual class, like, or vice versa in an actual class. So what it basically means is that this confusion matrix got me confused somehow. Okay, so this is going to have rows and columns. So particularly this is helpful for measuring or understanding the performance of our classification algorithm, which we used at this point of time. Each row of the matrix represents the instances of a predicted class, while each column of the matrix represents the instances in actual class, or it can be the other way around. So here the confusion matrix at this point of time indicates that there was 504 instances of class 0 that were correctly classified and 486 instances of class 1 which were also correctly classified. There were no false positives or false negatives because all of these are zeros and zeros, right? So in summary, we can say that the output that we just generated from this script is that the model performed perfectly, achieving 100% accuracy in classifying both the classes of 0 and 1 with no misclassification. At this point of time, a question might arise that how can this model get 100% accuracy? That is because the feature which we have just taken into consideration at this point of time is network ingress or egress traffic, which is very easy to classify based on the source and the destination IP address. So that is the reason we are getting 100% accuracy at this point of time. So I basically took this as a source and destination IP address so that we can just quickly classify the data and label the data and use it with a machine learning model. So that was the entire motive of using that ingress and egress as features. But we can expand this by taking other features like let's say like the protocols or several other factors into consideration and training the machine learning model to actually use it in real use cases. Now, if anyone would be interested in having a real data set of real live traffic of various computers and nodes connected, then I would recommend visiting the website. I'll just open up Safari to show you the website. Okay, we can just go to cgrw.org/links. So this is basically the website which we can go to. So this will open up a super sensitive search where we can write, remember that this is case sensitive, so dib/ds. So this is the search prompt which you need to type and click on search. So now it's going to redirect you to a research article, that is cyber attack evaluation dataset for deep packet inspection and analysis. So these are all the details which you can go through. We can see that there is I'll show you quickly the network diagram over here. So this is the network diagram which we have showcased in this entire data set. So there are multiple nodes or computers that are connected. We have captured the data using Wireshark. We have used a host network. We have used 2 VLANs. So this is structure which we had prepared to analyze the data and traffic. So entire traffic has been taken on this set of machines that we had connected. So there are 10 computers connected to router 1 on VLAN on. So now what we can do is I'll just show you one more thing over here. So all these files, you're going to get it inside the dataset, that is pcapng file, the xlsx file, the csv file format, the SQL file format. So all these are already prepared, ready-made for you. So you can just go through that and analyze the data packet capture. So we have already given the steps, also how we can analyze the packet. all those stuff has already been provided, and we have also used the dbeaver app in this case. As you can see, we have showcased various attack formats that we have used, like distributed denial of service, brute force, web-based enumeration exploitation, ARP spoofing. So all this kind of attacks are already showcased in the form of packets that are present inside this data set, which we have shared. Also, what we can do is you can just go down over here at the extreme end of this research article, and you can see uh, somewhere you will see, yes, data availability. So this is the Mendeley data set which we can show you up over here. So this is from here you can just download all the files of cap1. So this is a 601 megabytes of file which you can download and do research on. Or if you want, you can directly go to the IEEE data port as well. This status is also posted over there. You can just go to the same links. This again, paste this CIED IEEE data port. So this is the search term. Remember, this is case sensitive. I'll also give the direct links in the comments below. Let's click on search. So this will open up the IEEE data port. So this is the entire data set is published over here as well. Now, if you use it for research purposes or for enhancing the data set, or like using this data set for your own research purposes, remember to cite my data set. That will be really helpful for me. So that's all for today's video. Thank you so much. I know this video got a little long because we had a lot of stuff to do. Thank you for watching. See you again.